In this question, we're asked to find the exact value of the integration 4x sine x over 2 between the limits of 0 and pi over 2. So in terms of the solution, we think about using integration by parts, and that's the equation that we can use. So we can let u equal 4x, and we can let dv dx equal sine x over 2. So at this point, we need to think about how we're going to integrate this to get v, and we're going to have to think about how we differentiate u to get du dx. So u is equal to 4x, which means du dx is equal to 4. And if dv dx is equal to sine x over 2, then the integral of that would be negative 2 cos x over 2. Now, if we think about this carefully, by considering differentiating cos x over 2, we know that we get a negative half sine x over 2, which means if we integrate this, we get back to the original function. So we integrate it, and what we can do is extract out the negative half outside the integration symbol to get cos x over 2. Well, if we just want to work out the integration of sine x over 2, we just multiply both sides by negative 2. And so that's our answer there. And that matches up with what we have here. Now, in terms of carrying on, we do direct substitution of all these different functions. And we can see that we have 4x as our u, we have sine x over 2 as our dv dx, and then we have u, which is 4x, and we have v, which is negative 2 cos x over 2. So the negative 2 times the 4x gives us this negative 8x term. There's the minus sign. And in terms of the second integration there, we've got v, which just happens to be negative 2 cos x over 2, times du dx, which happens to be 4. So we're going to get a negative 8 term here. Now what we could do is we can extract this out in front of the integration sign, and we get a positive 8. So we're just left with the integration of cos x over 2. So how do we do that? Well, in terms of thinking about integrating cos x over 2, we can think about differentiating sine x over 2, and this would give us a half cos x over 2. Now we can think about integrating this to get back to our original function, and we can also extract the half outside the integration sign to give us sine x over 2 plus the constant of integration, and then we can simply multiply both sides by 2 to give us an answer for the integration of cos x over 2 as 2 sine x over 2. So we get 2 sine x over 2 when we try to integrate this. Now we're going to use this fact. So the negative 8 comes out, gives us a positive 8, and we also got a 2 sine x over 2 term when we integrated cos x over 2. And so the 2 times the positive 8 gives us 16, and so that's where the 16 comes from. The negative 8 here can be extracted out to make life a bit easier when it comes to calculations. There are our limits of 0 and pi over 2, 0, pi over 2. So we now start to evaluate these limits. So for the next line, what we can do is start substituting in these values. Now, cos of 0 is 1, but it's being multiplied by 0, so this term's going to disappear. And sine of 0 is 0 itself, so this term is going to disappear. In terms of thinking about cos pi over 4 or sine pi over 4, well, what we need to do is we need to think about a familiar triangle that we've seen in trigonometry. And it looks like this. So we're going to think about what this would look like when we're thinking about the sine or the cos of pi over 4. And this is going to give us 1 over root 2. So we can start substituting these values in, and we end up with the next line where pi over 2 times 1 over root 2, that term's gone, and we've got the 16 times 1 over root 2, that term's gone. So we're nearly there now. Just another line or two before we can get the exact value that we need. So we can simplify to this. And then finally, we can simplify to the final answer there, which is 8 root 2 minus 2 pi root 2. We've got surds and pi in its exact form, and so that's the final solution for this question.